Tonight, everybody, I have a rewording of a competition problem that wasn't worded, they didn't use the word partition, but this is a nice example of a partition. You know, by partition, I really mean a disjoint union. In this case, the union is all the natural numbers or all the positive numbers. And what we mean by a disjoint union is that any pair, they're pairwise disjoint, meaning their intersection is vacuous. And so for any I not equal to j, the intersection would be equal to the vacuous set, the null set, or the what we call the empty set, which is a little circle with a slash through it. Okay, and again, by construction here, these t sub i's, their union is all natural numbers, all positive numbers. It's very clear. 1, 2, you can just see 3, 4, 5, 6, 7, 8, 9, all the way out. The next one would end in 30, and you can, it's clear that the union here is all the natural numbers, and also I better say that I is not equal to j up here. I not equal to j. So that's what we mean by partition. Now they didn't use the word partition on this competition problem, the SMO Open 2022 problem 2. Okay, now another thing to note here that's very clear, you guys, when you use absolute value bars with set notation, that's nothing more than the cardinality or the size of the set. So in this case, this is very simple to see what the size of each of these sets are. They're definitely 2 raised to the index, right? 2 raised to the I power. Here you would have 2 to the first power, which is 2. Here, let's just do this one. The size of this one would be 2 cubed equals 8. Okay, that's the cardinality of the set. Okay. Now the problem is actually quite simple once you decipher what everything means. We're supposed to find the sum of all the integers in the union of the first 10 sets constructed thusly. Okay, so let's see what that entails here. And it's pretty clear, this very first statement is pretty clear. If you remember finite geometric series, we're unioning the size of the 10 sets, okay? And like I said before, it's 2 to the I, so this is 2 to the first, 2 squared all the way up to 2 to the 10th. Now, y'all, this is the result of what they call a finite geometric series. And those of you familiar with that, and it's a very common competition type formula, but this very first term right here is the same as 2 times 2 to the 0, right? So you see the what they call the common ratio and the first term are the same thing, all right? And so that's slightly confusing maybe, but right here this would be 2, very last term would be 2 times 2 to the 9th. And there's a way to multiply by the common ratio and actually get this formula here. I won't go through that, but so notice that we do have 10 terms here. We do have 10 terms. You start at 0 and you go all the way up to 9, right? This is the last term. This is 2 to the first, of course. And so this is the result you get. Again, I won't go through the derivation, but you do get a sum of 2,046 numbers. Now, again, that just means there's 2,046 numbers in the first 10 sets constructed like this, okay? Now, but we're not done because we have to actually sum those numbers up. And you know that we have to sum starting at 1 because that's just how it's constructed. We started at 1 and went all the way out to however far, you know. So, so we can write this. This is very simple result also, or common result, shall I call it? Not simple if you haven't seen it before. But this would be equal to the sum of the integers contained in this union would just be 1 plus 2. And this part's slightly sneaky, you know, even though it's kind of obvious once you think about it, it took me a moment or more than a moment. But so ... plus 2046. And of course, this is the super well-known result about triangular numbers. Okay, and so that's equal to 2046 times 2046 plus 1, which is 2047. all divided by 2. This is a popular formula when you're doing the limit of the sum definition of the Riemann integral. All right, now I don't know how to. I'm gonna. If you want to wait on this, I'm gonna go ahead and put that in the calculator, folks. Let's see here. 2,046 divided by 2 is 1,023, right? So we'll do 1,023 times. This is gonna be a number in the millions, 10 million or something. 2047 equals 2. Wow. Okay, this one is 2 million. Yeah, I'm not going to double check it just in the name of finishing the video, but this is what I got when I use the calculator. But the correct answer is this expression. They may even let you leave it that way, and you probably wouldn't even lose points if you didn't carry this out. I don't know. But it's weird on this test, they want them to write in terms of floor function for some reason. Don't know why, but this is the answer right here, and that's how it goes, folks. And again, folks, I want to emphasize that this was a modified problem. The SMO problem that just did the union of the first 8 sets. Okay, I did the union of the first 10. I used the word partition, and the way I worded it was substantially different, but it conveys the same sort of meaning. Their way of wording it, in my opinion, was just a little awkward, and this is slightly better, although you have to know the meaning of a few more terms, I guess. But anyway, that's all. Thank you for viewing.